All right, welcome back. This is Dr. Matthew J. Traum. This is the second video of the 7th lecture in the engineering design course. We just finished talking about this slide when you went on your break. So here's where we'll pick it up. We're talking about product performance specifications procedure, and it's a 4-step procedure. And we just finished talking about the first step, which is the consideration of different applicable levels of solution generality. So now that we've made this consideration, we're ready to move on to the next step, which is determining the generality level at which we are actually going to operate. Now, remember from the previous slide, if I am too specific in setting my specifications, then I end up with a very limited number of solutions which are very similar to each other. If I'm too general, then I end up with a lot of different solutions that have very little to do with one another, and the design space is quite expansive. So I can actually use this as a design engineer to my advantage as I am interacting with the client in determining how far away from the client's existing base of expertise they really want to traverse in whatever design problem they brought in the design engineer to solve. So over here I've got kind of this arrow which is representative of a range of generality, with the highest generality corresponding to the desire of the client to diversify their business well beyond any established product. So remember, with high generality, you end up with a very wide and varied design space. There's a lot of flexibility for the design engineer to come up with a variety of different solutions. And so if the client does in fact want to diversify their business beyond their current core skill set, you might, as a design engineer, intentionally set the generality of the specifications quite high in order to achieve some brainstorming and some ideation that's well beyond the current core expertise of your client. Here in the middle is likely where you're going to spend most of your time as a design engineer. This is immediate generality. So this is a client that either wants to bring on a new product that's well aligned with their existing products, or add some new features to existing products. So it does allow some flexibility for the design engineer to kind of stray away from the core set of expertise, excuse me, the core set of products that the company already has, but it does constrain the design process somewhat in that you're not off looking at completely different solutions that have nothing to do with the client's existing expertise. So that's usually where you want to operate. And then there are some cases which that corresponds to lowest generality, that's here, where the client only wants to make slight modifications to an existing product, so just very small changes. And in that case, having a very small constrained design space and not a lot of variety of solutions is actually advantageous, because you don't want to upset the client by suggesting something that's really beyond the scope of what they're interested in doing, given that they only want to make slight modifications. So again, there is this range, and you as the design engineer do have some ability to control that range, and you can use that control to your advantage to align your creative design process, your ideation, the design solutions that you ultimately come up with through the specifications, align those to really what the customer wants, and communicates to you what they want as a result of the design process. So let's move on to the third step, which is to identify the required performance attributes. So the first point here is that performance attributes are derived from design objectives and functions. I've talked about this before. This is essentially the translation of the qualitative, incomplete customer needs into the quantitative, complete, well-specified product specifications. And so it's your job as the design engineer to kind of translate the objectives and the functions that the customers communicate to you into some quantitative metrics. So as I said before, these quantitative metrics should be independent of any particular solution. And the reason for this is that solution-based statements, as opposed to performance-based statements, are unnecessarily restrictive. If you essentially restrict through specification that a particular solution has to be made of a certain material, for example, or has to be made up of a particular component, you've already limited the design space so severely that it's very difficult to be flexible and to come up with alternative and good creative solutions. So if you're faced with a situation where the client keeps trying to specify a solution-based um, solution to a design problem, it's good to kind of sit with the client and figure out what it is about that particular product, that particular solution that's so appealing to them, and use what they tell you as a way of kind of fleshing out and expanding the customer needs statement. So there's a lot of things that whatever solution they have in mind, a lot of attributes of that solution that's appealing to them. And so a lot of those things might initially be left out of the customer needs statement. And through that conversation with the client, you can put them in to the customer needs statement, still allow yourself the flexibility of being able to explore the entire design space and not be constrained to a particular solution. So that's the second point. The third point is that the final performance attributes list must contain all the conditions that a design solution proposal should satisfy. So you really now have to cross-check and cross-reference once you come up with excuse me, the final performance attributes, a list of specifications. You really do have to go back and check to make sure that everything that's been articulated by the client in their customer needs statement is in fact fulfilled by the final list of performance attributes. And then finally, even when you get to that point where you're essentially done, you may still need to distinguish requirements that are demands from those that are wishes. And the real difference there is that demands must be met. You don't have a choice. You have to meet demands in order for this product to function the way that the client needs it to. Whereas wishes, which still end up in the customer needs statement and even end up as part of the design requirements, those are things that the client would like, if possible, but are less important and can be maybe not ignored, but at least diminished in terms of how much attention you have to pay to them. And we'll see as we move through the design process, we actually will get to a point where we start to weight the importance of specifications. And it becomes quite important to understand the difference between demands and wishes. Demands receive a much higher weight than do wishes as you start to quantitatively compare one to the other. Okay, so I've hit my 7 minutes, so I'm going to move on here to the next slide, and this is where we'll start after your next break. So see you in a moment.